All right, let me just go back to the notes. Okay, so again, it's back to that sage thing. I know it seems like a repetitive loop to you, but we're trying to encourage you to start to use software. And the software we're trying to encourage you to use, at least initially, is Sage Math. You're going to start to be exposed to more computer algebra systems. There's a tremendous number out there. Sage Math is certainly an important one. There's others, though. I'm not saying this is the only one. The advantage of Sage, though, it's free. Again, if you go to the website, you could run these lines of code on the website just by using the CoCalc. All right, CoCalc is an interactive web-based version of Sage. I'm going to use my own computer to do the computations because I want to depend on my computer. So I'm going to type in these commands here. We've done this many times before. Reset. What's the next thing I want to type in? Oh, X and Y are variables. I'll put this down for you. And again, this is really good habit to get into, defining your variables in computer science when you're coding. And this is using Python. It clearly states it up there, by the way, we're using Python. And then, I'm going to put spot. I'm getting a little tired. Again, you can hear me say this over and over again. Yeah, I typed this stuff in. But I'm going to copy paste. All right, implicit plot. All right. What does it do? It gives me something. It gives me a circle. All right. So let's go back and look at that and see why it's a circle. Well, looking at it, I'm looking at this thing, and this really, if you look at this equation over here, this is clearly an equation of a circle. And we've done that before. All right, we've done that before. You notice what it says in the output. It says launch the PNG viewer for the graphic object consisting of one graphic primitive. Well, that graphic primitive is in the blue. It's a circle. Pretty simple. Let me close that out. And I want to go to the next line of code. And next line of code is this one over here. I'm looking at it, and it's an implicit plot again. And I'm just going to type it in. And what do we get? We get a parabola. All right. Was I expecting a parabola? Yes, I was expecting to see a parabola. It's in the proper form of parabola, where I could read the vertex. The vertex would be 1, comma, minus 1. Well, looking at it, I'm seeing that. And again, you might be confused by these things, but there are axes here where you can read the vertex off. All right. I want to go to a different software. The reason for that, I want to claim to you that the reason for different software is that, I'm not going to say Sage is the only product you should learn to use. And I'm not saying the ones I do show you are the ones that you want to learn to use. What I'm saying is there's tools out there and you need to get comfortable with the use of tools. But before you can use a tool, you're going to have to develop a skill set. And that skill set is going to be basically, do you understand what we're doing? So looking back over it, I want to claim when I did the problem number 6, what does it say? Find a focus, directrix, vertex, axis symmetry for the parabola whose equation is. Well, I'm going to go to Grapher now. All right. I like Grapher, but that doesn't mean you like Grapher. You need to find software that you like. And also you need to find a subject area that you like. All right. And I say like, I'm not going to say love. You don't need to love something, right? But you need to like it enough that you're willing to work at it. If you dread something though, it's really not going to work out for you. You don't want to dread this stuff, right? But what do I got over here? I'm graphing out, y plus 1 squared equals 8 times x minus 1. And what I did was I graphed it out. I typed it in and I graphed it. It's the parabola, right? That's all it is, a parabola. And, I also graphed out a point. I want to point out what point we graphed out. I graphed out the point, and if you look at it, we're looking at this point over here now. What's that point going to be? That point over there is 1 minus 1. All right, that point is 1 minus 1. Let me just show you that. I'll open up, edit the point. 1 minus 1. All right, let me cancel. I also graphed another point, this point over here. And what's that point? That point is the focus of this particular parabola. And where is that point going to be? At 3 comma minus 1. All right. What else did I graph out? I graphed a line y equals minus 1. Now, what's that line? That's a green line over there. That's the axis of symmetry for this given parabola. That's the axis symmetry. What's the other line I put down? The directrix, and that's going to be x equals minus 1. I want to claim all those answers are listed in the key. They say the vertex is 1 minus 1. Directrix is x equals minus 1. They talk about the p being 2, the focus being 3 minus 1, the axis symmetry being y equal minus 1, and the graph. Now, granted, when I put the graph down over there, it's the same graph I got over here. What's different about it? Maybe I use color over here. Maybe I explicitly put the points down for you, yada, yada, yada. Here's the deal. You got to get familiar. if you're thinking about moving forward in a STEM related career with using software, most real world problems can't be done by hand. A computer needs to be used to solve a problem. You're gonna have to learn to use a computer. Now, I'm gonna say over here, the problems that we're doing don't require a computer, but we're trying to transition you from something that doesn't require a computer, learning to use a computer, to hopefully advancing your careers forward to so when you see a problem that can't be done by hand, at least you know the computer's available to you that can actually do these problems over here. Thank you.